So one idea that I'm kind of building on is this idea of literate statistical programming. So this comes from the literate programming idea, which is that, so here you think of an article as a stream of text and code. There's analysis code that has, it analyzes the data or does something with data. And those are chunks, and then there's each code chunk kind of does something with the data. There can be presentation code that kind of formats results. And then there's text kind of all around that, which explains what's going on, presumably. And these literate statistical programs can be kind of weaved to produce a human-readable document, and tangled to produce a machine-readable document. So this all comes from this idea of Don Knuth, right? So, and so the literate programming concept requires two things. One is a documentation language and a programming language. And so there's one particular package, so I should have mentioned that I'm going to be talking mostly about the R statistical kind of analysis environment. And so there's one particular package called Sweave which uses LaTeX as its documentation language and R as its programming language. So, and it was developed by Fritz Leach, and it has a nice website. And there are other kind of combinations that you can use. And so one thing that I was interested in doing is taking the kind of definition that we had of having analytic data and computational and analytic code, and say, okay, well, let's take the process here. Presumably the article is available because it's in a journal. And then let's make this part available too. So the idea is that we'll kind of store these things in some sort of database of sorts, and then make it available to the reader. So the reader kind of wants to go this direction. They want to take the article and dig in. And authors are kind of taking their data and they're going that way. They're producing articles. And so the idea is to take these kind of aspects of the work and kind of store them in a database to make it available to readers. So in the kind of literate statistical program framework, you have like your paper here, which has text and code and text and code. You take the code chunks and you store their results. So the code chunks kind of do something with the data. You store the results in the code in some database. You publish essentially the database part along with the paper. And then this is the paper here, which is generated. So you generate the figures and the tables from the material stored in the database. There's kind of two packages that we have. One is this called Cache Sweave, which I won't talk about today, but it interacts with Sweave. And the other one is called Cacher here, which is a standalone package. And the idea is that it assumes that you have some code in an R file, and basically it kind of reads your code, evaluates it, and stores the results in a kind of a key value database. So the R expressions, so the code expressions, are all given kind of a SHA-1 hash value, so if there are any changes, that they can be tracked and code can be reevaluated necessarily. And the idea is that you kind of put everything, the code and data, in a package that you could just give to someone, right? And I call this a cacher package. So the other people can get the analysis clone the analysis and look at subset of the codes or inspect specific data objects. And one assumption that I've made is that other people do not necessarily have the resources that you have. And so they may not want to run the entire Markov chain Monte Carlo simulation that you did to get the posterior distribution or the histogram you've got at the edge. So they might just want to look at specific end products of that, and then maybe when they see the end products, they say, oh well, actually maybe I do need to look at the whole MCMC. But the idea is that you kind of peel the onion a little bit rather than just go straight to the core, right? So the model is basically that you have some code source file. There's code that goes in, there's data that goes in, and out comes results, right? So as an author, the idea of Cacher is that it kind of parses the source file. It creates directories and subdirectories for storing things. And then it evaluates each expression. And also, if you run it multiple times, if an expression hasn't changed, it won't run it again. So it just load as it runs expressions, it caches the results to the database. So if you run it again and nothing's changed, you just kind of load the results back from the database. And then it writes out a bunch of metadata for each expression. And then once you've kind of evaluated your whole analysis, and granted this might take a long time, all the kind of intermediate results are stored in a database, and you can kind of wrap that up into a package. So that's the idea here with this cache package function. And it becomes a zip file, a package, and it can be kind of distributed to others. So that's kind of what happens as an author here. And so a very simple analysis. You're loading some packages. You're loading a data set. You fit some simple linear model. And then if you want to summarize what the fit was, look at the regression coefficients, things like that. And then you make a plot here. So here you're just plotting some diagnostics here. So the idea is that any expression that that does something, then the results of that something are stored in the database. If an expression doesn't do anything, like maybe it just prints something to the console, then nothing is stored.
So when you say does something, you mean creates a variable or modifies a variable?
Right. So in R, if something is created in the environment, then that is stored.
Okay.
Yes.
But like you said, figure does not count.
The figure, so yeah, right. So we don't store the figure itself. Right. And then the idea is that the package would have an identifier like SHA-1 here. And then, so the idea is you could say, if you were writing an article, you could say, well, everything in this article can be found in this package, and here's the identifier string. So it's ugly, but you can just use you can use the first 4 characters, and that's usually enough to identify the package itself. So on the reader side, then, if you're reading something like this in a journal, you could say, okay, well, I'll take the string, and maybe I don't want to read the whole thing, but I'll just get the first 4 characters out, and you can clone the whole thing, right? And so, I'll get to where it comes from later, but and the idea is that you can see, so you can clone it, you can see what files were cached there, and then kind of go through the analysis. So some local directories are created, the source code files and the metadata are downloaded, but the data themselves are not downloaded initially, right? Because it could be a lot, right? And so that's not done by default. But references to the various data objects that have been created are loaded, so that so the idea is that these are lazy loaded into the environment. Once you want to look at something, then it gets downloaded onto your computer. And so the idea is you can look at the code, and so this is just some simple analysis that I've done. You can make a graph of the code. So this takes all the data objects in your kind of this simple analysis that I've done, and kind of graphs how they've kind of come together. So like these 3 things, the cities variable, the classes, and this vars thing came together to create this data, and then data was combined with this quasi-Poisson function to create estimates, and then and the estimates were later used to create this effect in standard error. So I mean that's the kind of rough graph of how the analysis worked. And so the idea is that, okay, well, someone might look at this, and of course, you'd have to do some reading to figure out what exactly is going on here. But the idea was, if you were interested in this and knowledgeable a little bit, you could say, okay, well, I'm interested in this data object. What went into the creation of that data object? And so this object code function, you can grab the name of the object, and it will show you the specific lines of code that were used to generate that. So if you have a file, there may be many lines of code, but only some subset of which were important to generating a specific object, right? And so these specific lines, so it turns out it's just 1 through 5, but these specific lines of codes were what kind of created this data object, right? So there may be different types of objects in the analysis, and you can kind of hone in on some of them and say, okay, what was the code that generated this object? You can also execute the code with the run code function. And what it does is it runs the code, but it runs it in a way that it just loads things from the database without actually executing code by default. So if you just kind of want to run it and see kind of some results at the end as a first cut, then it's not going to do everything from scratch by default. And so it's a lot faster on the first go. But then, of course, things that aren't stored in the database. So if you make a plot, it's still going to have to generate the plot because that's not stored in the database. But by default, it just loads objects from the database to make things faster. You can, of course, force it to just run everything from scratch, and then it will just it will do all the calculations from scratch. But there may be, for example, some expressions that you want to run from scratch, and some that you just want to load from the database because they're going to take a long time. But they aren't that important, maybe. So the check code function evaluates all the expressions from scratch, so it doesn't load anything from the database. It runs it all straight away. And then the evaluations are checked against stored results. So the idea is that if a function creates an object, when the author created the package, the kind of signature for that object was stored, so that if you create the object again, it'll check the signatures to see if they match. And of course, you've got to set things like random number generator seeds for this kind of thing to work. And then there's another this kind of side function that checks each individual data object to see if any corruptions. It basically checks the signatures. So you can load you can look at specific data objects, and so with this load cache function. So what the load cache does is it just loads pointers to specific data objects that may be stored on a server or something like that. And the idea is that once you print something out to the screen, or you want to make a plot, anytime you access the object, it will transfer it from wherever it's coming from. So here it's transferring from the cache database file, and then each object has a signature, and that's the signature. And then it shows you what it is. So once it's loaded into your system, it's loaded for good. You don't have to do it every single time, just the first time. And then these are just different things that you might want to look at that are transferred from a server. So the basic idea of this package is that authors can kind of create their kind of package their analysis in some sense, and then just give it to people. And then readers can download the analysis and look at specific objects, or maybe rerun the whole thing. But there's some flexibility in terms of not having to kind of recreate the entire environment if it's a very complicated type of thing. So one of the goals is to be mindful of readers' resources and to only kind of efficiently load things that are needed.